Hello everyone, welcome to Chem 261, Organic Chemistry 2. In this semester, we're going to begin in Chapter 11. Chapter 11 will cover the substitution and elimination reactions of alkyl halides. Before we begin our discussion of the reactions of alkyl halides, I wanted to briefly discuss some of the uses of organic chemistry. This semester, we're going to cover a ton of chemical reactions, and so it's a good idea to maybe discuss why we are learning some of these reactions. We'll get to see some of these examples throughout the semester, but for starters, I wanted to show an example of how chemists will use organic chemistry often to um, synthesize compounds that are difficult to make. One example, a perfect example, is Taxol. Taxol is this molecule shown here. It is a compound that was initially isolated from the Pacific yew tree. It's a tree that grows out in the western U.S. It takes several centuries for a tree to mature, and scientists have found that a very small amount of Taxol could be isolated from the bark of this tree. Unfortunately, the process usually leads to killing the tree, but this compound is important medicinally because we can use it to treat several types of cancer. So despite the fact that it's very difficult to obtain from nature and the fact that it's a very complicated structure, it has a lot of useful properties. So many chemists have over the years worked in the lab to synthesize these compounds through various methods. Many of the reactions you'll learn this semester have actually been used to make compounds like Taxol and others. When an alkyl halide is mixed with a nucleophile slash base, there's two possible reactions that can occur. For example, a base could react with an alkyl halide by attacking the same carbon that the halogen is in and replace it, essentially doing a substitution reaction. Another possibility is for the base to remove a hydrogen that is an adjacent carbon to the carbon that contains the halogen. By doing that, both the hydrogen and the bromine will be eliminated, and as a result, we will obtain a double bond, as you can see here in the product. Overall, this is considered an elimination reaction. One of the terms that you should become familiar with is leaving groups. So in these examples, both the substitution and the elimination reaction, the bromine is the leaving group. It is the group that leaves after the nucleophile slash base does the substitution or elimination reaction. Notice that I am using the term nucleophile slash base because very often nucleophiles are bases and vice versa. Nucleophilic substitution reactions are those substitution reactions where a nucleophile replaces another. A couple examples are shown here. For example, the acetate ion will attack the carbon that has the bromine and replace it. In this example, the iodide replaces the tosylate group to produce an alkyl iodide. The tosylate group here is a new group that you probably have not seen before. Its structure is shown here. So it is a toluene group attached to a sulfonate. So sulfonates are when we have a sulfur attached to three different oxygens, and The tosylate group overall basically behaves like many halides as far as being an excellent leaving group. So we can replace them um, by a nucleophile attacking the same carbon that contains the tosylate, and similarly to what we saw with the bromide in the first example on this slide. Notice that substitution reactions around primary and secondary carbons usually occur with inversion of stereochemistry. So an example is shown on this slide with two secondary alkyl halide and here an alkyl tosylate. And you can see that the bromine is facing towards us while the product contains the acetate group facing away from us. In the second example, the tosylate is facing up, and then in the product, the iodine is facing away from us. As I mentioned a few slides ago, in this chapter, we're going to discuss substitution reactions and elimination reactions of alkyl halides. As far as substitution reactions, there are two common mechanisms, the SN2 and the SN1 mechanism. SN2 stands for bimolecular nucleophilic substitution reactions, while SN1 stands for unimolecular nucleophilic substitution reactions. We'll discuss these two mechanisms over the next few slides in more detail. Later on, we'll discuss the three possible mechanisms for elimination reactions.